Hi guys, in this video we will be talking about range and codomain. But what we understood from the previous video is domain. Domain is what input we can take. Range is the output that gets generated. And why do we have this another name called codomain? Codomain is the set of values which possibly contains our output. So we can say that the three important parts to a function, domain, codomain, and range. Domain essentially means into the function, what can get into the function. Codomain means what may possibly come out. And range is a set of actual output. And that's what we will be actually talking about today. What actually comes out is range. Now, so codomain and range, they're just special names to certain sets. When we write down F is from A to B, always remember B is the codomain. Thus, the second question ever asked in terms of function is, what is the range of? The first question being, what is the domain of a particular function? Second question generally is, what is the range of a given function? Let's understand this with a very simple example. Say, suppose the machine squares the input. Suppose you have a function which is from R to R. And when I say machine squares the input, that means I'm talking about the function fx equals to x squared, right? Now, what I have said is that function is from R to R. So we are saying that you can take all possible real numbers as the input set. So whatever numbers will be plausible, just take those. In fact, since the formula is x squared, I can take any real number as an input and I will be able to square it without any contradictions. And B, which is the codomain, is R again. So we are saying that when you will square any real number, you will possibly get a real number, right? But since I have the formula x squared, I know how to exactly square and find out the value of the output. So therefore, I know that when I will square any number, if I take negative number and I multiply it 2 times, that's what square is all about, I'm going to get 4. So if I'm taking a negative number, I'm multiplying it 2 times, I'm getting positive number. If I take positive number and multiply it by itself only, I'll again get a positive number. So that means what is happening here is that whatever number that gets generated is always greater than or equal to 0. In fact, it will just be 0 when the input itself is 0, right? So what comes out is positive. What comes out is greater than or equal to 0. So hence you will be able to tell what the range for this function would be. The range for this function would be all the y's that are greater than or equal to 0. In other words, you will be able to say that the range is a set called R plus. R plus means you're only talking about positive real numbers, including 0. Or in terms of interval, you can say that 0 to infinity, everything is a part of the range. Simple. So what's the difference between codomain and range here? Range is the actual outcome and codomain are just the possible outcome. So my input is all real numbers. I would say, okay, real numbers would come out, should come out, right? But I can then find out exactly what numbers are actually coming out. That's the difference between codomain and range. There could be scenarios where codomain and range are the same. For example, if I take a function fx equals to x itself, what's going to happen here? Suppose, again, my assumption is that input could be any real number and possible output should also be real. In this case, if somebody asks me, okay, what is the range for this function? The answer would be, if I'm putting in any number x, x is actually coming out. So when I put 1, 1 comes out, 2, 2 comes out, -1, -1 comes out, √2 comes out. So actually, all real numbers will get generated. I don't have any restriction here. Neither do I have any restriction uh, for the domain. Input could be any real number. And actually, since the mapping is such, the same number comes out. The machine is such that it's just giving you that number itself. The input itself comes out as an outcome. So hence R is the range. This is an example where what's happening? Your codomain and range, they are the same. I'm going to talk about this scenario later, but here I just want to give you the picture that yes, range and codomain can actually be equal to each other. Otherwise, can you see a relation between codomain and range? Clearly, I can see that range is something which is either equal to the codomain or it must be lying inside. For example, if this entire set is R and this is R minus, this is R plus, then the set of positive numbers in this example, it's a part of the codomain, right? So range is said to be subset, either proper or equal subset of the codomain, because codomain conceptually means that codomain is the set of possibilities. So codomain consists of the range, or in other words, you will find your range within the codomain, or there could be times when it's equal to it. It's a very common question asked to students in any paper, any examination, how to find range, how to find it. At times, finding range is not very straightforward. Many a times you have to use your logical reasoning here. You have to use some manipulations to figure out what would be the possible range. Now, I'm going to carry forward the examples that we did in the previous video to find out range of those functions. So range means the end product. What values finally this function will take? What is your outcome? Let me take the first example that we took in the domain as well. If I have the function y equals to 1 upon x, we know that there was a problem with the domain. We have to delete 0 from the set of real numbers, and that is what we can take as input. We cannot take 0 as input. Now, if I may ask you, what would be the output of this function? You pick any real number, plug in here. That is, if you put, say, you take x equals to 2, your y will be equal to half. If you say put x equals to half, y will be equal to actually 2. And so on and so forth. Do you see any restriction coming in? Do you think there's any number which you will not be able to actually create? Well, in other words, if I would see this function, I can say that if y is equal to 1 upon x, I can say that x should be equal to 1 upon y, right? So do you think there is any restriction on y, like the way you had restriction on x? Do you think you have any restriction on y? Can y be equal to 0? Just the way x cannot be equal to 0 in the domain. Since x is equal to 1 upon y, even y cannot be equal to 0. Because when y is equal to 0, that would imply x is equal to 1 upon 0. That's infinity. What is infinity? Do you know where it would lie on the real line? Do you know exactly what it is? Infinity could be something for you. It could be something else for me. So infinity is a number which we cannot see. Infinity is not a finite number that I can see. So that essentially means that when x is equal to infinity, then y turns out to be 0. But can x be equal to infinity? X is approaching infinity. Always remember these two terms in mathematics, in discrete mathematics and higher level of mathematics. It's very important for you to understand where is your number reaching and where it is approaching, where it is equal to and where it is approaching. If this is 10,000 this is 10,000, then I will be able to plot it. I can mark it. Okay, X is equal to 10,000. But if it is infinity, then X is somewhere going to infinity. I cannot mark it anywhere that, okay, X is equal to infinity. It should be here. So what would be the range for this function? In the range, I cannot take 0. So hence, again, just the way you had domain, the range would be everything, all real numbers could be attained. But 0 cannot be attained. You will not be able to graph it at 0. 0 is something that you will have to take off from the range because you're not attaining 0. It is approaching 0, but you are not attaining 0. Y cannot be equal to 0. In simple words, if I say y is equal to 1 upon x, do you think y can be equal to 0 ever? You have 1 upon x. Your numerator cannot be 0. It is 1 upon x. Do you think it can be y, if y can ever be equal to 0? So this is very interesting way of finding out range. One of the best techniques, the basic techniques. You are given a function y equals to fx. That is, you have y in terms of x. Find x in terms of y and then deduce if you have problem with any y value, which should not be there in the range because you are getting a contradiction in terms of x, like what is happening here. For y to be equal to 0, x needs to be equal to infinity, but a number cannot be equal to infinity. It can approach infinity. So when x would be approaching infinity, then we can say y is approaching 0. But we cannot say it is equal to 0. That's why we have to take out 0 from the range. Let's use the same method in another question and be clear of this concept. Suppose fx is equal to x minus 1 upon minus x plus 3. I've already given you that the domain is x should not be equal to 3 for a simple reason, because that would have made our denominator 0. Because of that, we would want to find out what is the range of this function. So suppose y is equal to x minus 1 upon minus x plus 3. We would want to use the technique that I just told you. We have y in terms of x. Let's get x in terms of y. Let's try doing that. So what I'm going to do is I'm going to take the numerator out here to the left hand side, and that equals to x minus 1. So minus xy minus 3y is equal to x minus 1. What you have to think is in terms of, can I get x in terms of y? Let's collect all the x terms. So I have minus 3y plus 1 on one side. On the other side, if I take x plus xy, so this means that I have x multiplied by 1 plus y. So this means that we have x equal to 1 minus 3y whole upon 1 plus y. Now what you have to think, is there any y with which I can have a problem in the existence of x? Well, if I take y equals to minus 1, 1 plus y would become 0. Therefore, 1 minus 3y upon 1 plus y will not be defined. This would imply that is not defined. What is this value? This value is x. So which means that when y would be minus 1, if you put y as minus 1, you're getting an x which is not defined. It's infinite, right? So hence there is no finite x that can generate y equals to minus 1. Because had there been an x which could generate y equals to minus 1, then I would not have got infinity here for the value of x. That is why. So what have we just learned through these two examples is that what you can do, you can find x in terms of y and try to figure out what are those y values for which I don't have a valid x. Okay. Now let's work on a different kind of a problem. So let me give you fx equals to square root of minus 1 upon x plus 1. We've seen this question. Yes, we did figure out the domain for this function. But right now, we will be working on the range for this function. Let's try and figure out the range. What do I know about this function? It's a square root function. It's an even root function. I know that the input had to be positive, and that's how we figured out the domain for this function. Can we talk about the range of this function? Well, the input for a square root function is positive, so is the output. We know that a square root function is always greater than or equal to 0. So whatever will come out by putting the valid input, whatever comes out has to be positive. That's one thing I know. But can I analyze it beyond that? Can I analyze it beyond that? Well, yes. Now, the function fx is a square root. It will be greater than or equal to 0. So that means all other values would be more than 0 only. 0 will be the minimum value, and 0 is a value which this function is attaining when x is equal to 1. When x is equal to 1, fx is actually equal to 0. Now you have to think in your head with this analysis, how big can f turn? Well, in case x is tending towards 0, x is never equal to 0. We figured it out in the domain. X is never equal to 0. But when x is tending towards 0, the function is tending towards infinity. So if you would see graphically, the function would be reaching almost up to infinity somewhere, and infinity is the biggest positive number which does not exist. But it's the biggest if you compare with any other real number. Infinity would be the biggest positive number, right? So hence we can say that the function is approaching infinity. So how would you depict it in terms of what values are your output taking? Output could be 0 and it is moving up till infinity. So there are times when you can find out the range for a particular function by analyzing the function. Let me give you another question, and that might just clarify one doubt. What is that doubt? I already in the beginning said it's a square root function, and hence it will be greater than or equal to 0. So you must be asking now yourself that you already said it's greater than or equal to 0. We could have just said that, yes, the range is 0 to infinity. Well, will that happen every time I give you a square root function? That's why I'm going to talk about another function here. So let's take fx as square root of 4 minus x squared. This is also a square root function. What goes in is positive and what comes out is also positive, right? So I know that 4 minus x squared should be positive since we've not taken out the domain for this one. So I'm basically trying to find the domain of this one because that will help us. So this means that x squared should be less than or equal to 4. When is x squared less than or equal to 4? It will happen only when x is lying between -2 and 2. So what does it tell you? That x's can lie in the domain -2 to 2. This is your domain. These are the only real numbers your input x can take. Well, your range is associated to output and output is associated to input. You will put something as an input and that will generate output, right? So when I have a restriction that my input will be only between -2 to 2, let's see if it has any effect on the generation of your output. Let's figure out the answer to this question logically. Now we already know it's a square root function, so it has to be greater than or equal to 0. So therefore 0 is the minimum value of f, the minimum value that f can take. That's 0. Now you have to think in your head, what can be the maximum that f can go to? The expression that you have inside the square root is 4 minus x square. X square is a positive value. You are deducting a positive value from 4. So that means it will only make it smaller if you deduce something. But when x would be equal to 0, there is least deduction from 4. That means the highest value that fx can generate, that f can generate, is when x is actually equal to 0. So f is the max when x is equal to 0, and that value is root 4, that is 2. So that means that the functional values can go from 0 to 2. So the minimum value f can take is 0 and the maximum f can go is 2. That's what range is all about. Range is what is your outcome, the minimum value that your outcome can take till the highest value that your outcome can take. Of course, you cannot write each and every value. So you try to tell with the range. The word range also means that, right? From one point to another point, that's the range. So in terms of range for a function, it basically means the minimum value of the function to the maximum value of the function. Hence here, it will be 0 to 2. What I want to compare here with the previous question, in the previous question, it was a square root function. We got the range as 0 to infinity. But here, we're stopping at 2 because the domain is such. The function is valid for such x's only. Okay? Thank you.